Okay, now let's take a look at number 40 from that problem set. Let's see, a projectile is fired with it from a cannon whose angle of elevation is theta. Okay, it gives us all the information. It gives us that same equation we had before, the x equals v cosine theta t, and the y equaling v sine theta t minus 5t squared. Okay, what do these parametric equations give when theta equals 90 degrees? Okay, so basically think about that. If we shot it straight up into the air, what would happen? Well, if we look at this one right here, if we shot it straight up into the air, right, cosine of 90 is 0. That means it's going straight up and it's not going anywhere. So the x is going to be 0, right, in all cases. And for this one, it's going to be, let's see if I plug it in, right, it's going to be going straight up. So this is basically going to be 1. So it's going to be, do we have a v there? Right? It doesn't. We didn't get a v, so it's going to be vt minus 5t squared. Okay, so that's what's going to be if it's 90 degrees. Right? Basically, your trig goes away. Okay, and if you have v's, you plug those in. Let's see. B. Show that the projectile will hit the ground when t equals v sine theta over 5. Then show that the x value when the projectile hits the ground is such and such. Okay. All right. So if we're going to think about this, when it hits the ground, right? When it hits the ground, that means that the y equals 0. So, okay, all right, we have that for ourselves. Okay. Now, if we look at this, right? Yes, it's got a v sine theta, but that is a constant number. So if I'm going to solve this one, that's a quadratic. I always factor to solve quadratics, and I factor that out, and I get that. Okay, so what is this telling me? That one of the times it equals 0 is 0, and the other time is when v sine theta minus 5t equals 0. Okay, well, of course, when you shoot the cannon, of course, it's on the ground or whatever. You know, maybe that represents like a, coming right out of the muzzle or whatever. All right, but this is the other time it's going to hit. So we can see that v sine theta equals 5t. I divide by 5. And that gives me the time, all right, that it talks about in part B there. So show that this is when it hits the ground. Then show that the x value when the projectile hits the ground is such and such. Okay, so we'll take this and we'll plug it into this equation. So, all right, we'll plug it in, and that's our t. So we see v cosine theta. All right, we'll plug in v sine theta over 5 for ourselves right there. Okay, if we look at that, we can see we have v squared. Great. Right, we have sine theta cosine theta over 5. Hey, this is the right here. That's our sine double angle formula. If we had a 2 out in front, like we wanted to, okay, if we want a 2 out in front, I'll put it in the bottom as well just to make things equal. And then now we can actually say, okay, that's going to be sine 2 theta over 10. Okay, so now we've just proven, hey, that's my x value that's going to hit the ground. Okay, looking at part C. All right, for what value of theta will the cannon fire the longest horizontal distance? Okay, so we're trying to maximize what we have here. Okay, so what are we trying to do? We're trying to make this one as large as we possibly can, right? So we want v squared sine over 2 theta over 10 to be maximized. Okay. Now, if we had calculus, we could do this, and there's like a definite finite way to do it, but we're going to avoid that. We're going to think about how to make this one as large as possible. Okay. So you have a velocity, and that's already determined to you. We're just thinking about how to try to make this as large as possible. So we want sine 2 theta to be maximized. That's really what we need. Okay. Let me say that one more time. Right, the velocity is what it is. Okay, it's it's already determined for us. That's not going to affect how far it's going to. Well, it will affect how far it's going to travel, right? But that's already predetermined by the velocity. The angle, though, will determine how far. We want the x value to be as large as possible. We need this to be as large as possible. Okay, so what's going to make that as large as possible? Well, sine is maximized when the angle is 90 degrees, right? When 2 theta is 90 degrees, that's when the sine has a value of 1. That's going to make it as large as possible, which tells us the angle, maximum angle, is going to be 45 degrees for ourselves. Okay? Alright, so that's great. Hey Moose, how you doing? Right? Okay. So we have that for C. So if we're looking at D, right, graph the projectile path, right? So that would be basically using your calculator and plugging in just like we did on part 39. So you just plug in 15 degrees, plug in 45, plug in 60. Just look at how it's different. Okay, all right. So let's use the graph and calc. Even easier to use the graph and calculator, I think, is Desmos, because you can easily change those angles. E, find a Cartesian equation of the projectile's path. Is the path parabolic? Okay, Cartesian means just x's and y's. Okay, so if we have this equation up here, right, for ourselves, so we have this. We want to get rid of the t's for ourselves. So if I was going to solve for t, I think it's easier to solve for t in that one. So if I solve that one, I have t equals x over v cosine of theta. Okay. And then I can go and plug that into my y equals equation. T is here, so I have just changed a parametric. This is Cartesian right here. Now it's not the nicest Cartesian. We see the v's cancel each other out. Right? Oops, that should be cosine. Copied that down wrong. I think I was thinking about canceling. So it's doing that. So that's a tangent theta times x minus 5x squared over v squared cosine squared for myself. Okay. Is the path parabolic? Okay. Well, is it parabolic? Well, yeah, it would be parabolic. How do we know? Because we're going to have the velocity and angle given to us. These aren't variables. These are just placeholders for whatever we determine. So yes, it's going to be parabolic because x is squared. Right? X is squared, and that's all that really matters. Right? It's going to be parabola opening down. So that's how I know it's going to be parabolic there. Okay? And that's 40.